Hi, I'm Randall Heyman, a university mathematics academic. If you'd like me to make a video for you or your students during the coronavirus outbreak, please comment below or email me at coronahelpmathematics@gmail.com. I've done a lot on abstract algebra. There's a whole playlist, actually, Corona Help playlist on abstract algebra, and I just thought I'd put this up that we haven't sort of seen before. And this is a ring that has no numbers whatsoever. None. There are no numbers. So let's have a look here. Here's the set. Try and get something going here. Right. Here's the set here. The letters A through to H. So there's no need to have numbers or functions or polynomials, which we've seen before. In this case, these are just letters. You could, if you wanted, make them, cow, dog, swimming pool, whatever. In this case, the label is A to H. And we've got the two operations we need for a ring, addition and multiplication. Now, when we look at addition here, let's go with a different color. Here, just direct your line to this one. What this is telling us, if we have A plus A, we get A. Here, B plus A here gives us B. And if you like, go up to F. F plus A equals F. So this is the what's it called? The additive or the addition unity element. So this is the special element that when you add it on to any other element, it doesn't change it. In the integers, this is the number 0, because we know when you add 0 to any number, it doesn't change it. So that's interesting. Let's go over now to, let's get a different color. Whoops, let's get a different color. Let's try a nice bright green. Let's have a look now at here, this second operation, which we generally just call multiplication. So when we look at this A that we had from before, we discussed over here, we can see the effect of multiplying by A is that we get A. So for example, let's do D. D times A equals A. So this is what we see when we multiply things by 0 in the ring of integers. What else can we tell from this? Well, often rings have a multiplication unity element. This is this special number that when you multiply it by, it doesn't change the number. In the ring of integers, it's the number 1, that special number 1. Now here, when we look down, as we go down, just cast our arrow down, here we've got B. You can see when we multiply anything by B, we either get A or B. So that's certainly not acting as a unity element. Neither is C, neither is D, neither is E, neither is F. So what I'm saying here is when we go F times E, we're getting A. So this is certainly not the unity element, neither G and nor H. So in fact, this is a ring without a unit. Now, the other thing is that a lot of rings are commutative, which means that when we look at multiplication, we have that x times y equals y times x. Now, when we look at this, we can see that we don't have that being satisfied. Let's go to another color, and I've found a case here. Here, h times g equals a. So h times g equals A. But when I do g times h, I get g. So h times g does not equal g times h. So this is not a commutative ring. Now, some of you have followed my videos on ideals. This one here, if we look across here, we can see if we take b and we just start multiplying by b repeatedly, we get, well, b times a is a, and then b times a is a, b times b is b. So it looks like B is generating the set, or the ideal AB, because as we multiply things by B, whatever we multiply by B, we either get an A or a B. So there's some concept of an ideal there. So I hope you found this a little bit interesting, looking at a ring that has no numbers whatsoever. They're not functions, they're not polynomials, they're just letters. If you've got any questions on this or any aspect of mathematics at any level, please comment below any of my videos, or you could drop me an email at coronahelpmathematics@gmail.com.